Okay, so here's our first practice problem, starting with solutions. They want this to take you 1.5 minutes, so I'll tell you when 1.5 minutes is up, and go. That was 1 minute. And 1.5 minutes. I have 1, 2, 3, 4, 5 of you have answered. Let's deal with questions first before I go through and just work through the solution. Any questions, places you're stuck? We currently have 4 out of the 5 answers selected as a class, so we're all over the board on this one. What questions do you have?
How would I find this answer?
Okay, so that is an excellent example of how I don't want you to ask a question, but an excellent example of asking a question. Thank you for being the first person to ask a question today. I actually don't know who that.
I just didn't know like what calculations to do for it, so I just needed refreshing.
Okay. So when we're doing problems, let's start with what we're trying to find. Anybody want to tell me what you're trying to find?
We want the concentration.
Okay, so we're trying to find concentration, which means we are trying to find moles per liter. Do we have either given to us? Like, did they give us moles of NaOH solution, the final one, or did they give us volume of the final one?
They gave you the starting, but not the final.
Yes, they gave us the starting amounts of volume and molarity. Have they given us anything that has to do with the final, though?
The volume?
The volume. They've given us the volume of the final, yep. So I can just plug that in. And now I see that I need to figure out the moles of NaOH that are in the final solution, right? And since we're dealing with it's diluted, right? It's a dilution problem. That means the moles of NaOH that I start with are going to be the same as the moles of NaOH that I end with. So we're going to go where we just need to figure out moles. Does that help you get unstuck? I don't even know who's asking questions. I can't tell. Sometimes I can recognize voices, but sometimes I can't. So anyone who is stuck, does that get you unstuck enough to proceed forward from this point in time?
Yes.
All right. I'll give you like 30 seconds and then I'll work through it. See if you can beat me there. All right. That was 30 seconds. So let me just go through it. If I have 0.05 liters and 1 mole per liter, I'm going to have 0.05 moles. And that's everything in here has to do with NaOH. So 0.05 moles of NaOH diluted to 2 liters. So it's 0.05 divided by 2. So 5 divided by 2 is 2.5. So 0.05 divided by 2 would be 0.025. So it's A. Questions on that at this point in time? Give me thumbs if you beat me there. Hey, I'll take thumbs in the middle. You beat me to part of it. I'll take that.
I just multiplied 0.05 by 2 because I thought that 0.05 was the moles per 1 liter, and so then I multiplied it by 2 to get 2 liters instead of dividing.
Oh, okay. So let's look at that math real fast. I mean, you're close, right? You're on the right track. So 0.05 moles per 1 liter. If you multiply that by 2, what you're doing is you're increasing the amount of moles and not changing the volume, right? Because if you multiply it by 2, a fraction of 2 would be a 2 over 1. So you're multiplying the moles by 2 and not touching the volume.
Why is it 0.05 moles? I thought it'd be 0.05 liters because 50 milliliters is equal to 0.05 liters.
0.05 liters times 1 mole per liter gives us 0.05 moles. It's both. Okay, I think it was, Callie, did you ask that first question?
Yeah.
Do you see math-wise what you did?
Yes.
And do you understand conceptually why that's not dilution?
Yeah.
So you're on the right track there. What you should do, you do need to double something, but what you need to double is the volume. And the volume's in the denominator. So you'd be dividing by 2 instead of multiplying by 2. Does that help?
Yeah, thank you.
Yeah. Okay, Kaya, I think, was that you who asked the second question?
Yeah.
Did I answer it?
Wouldn't it be 0.05 liters per 1 mole instead of 1 mole over 1 liter?
No. If it was 0.05 liters per 1 mole, your molarity would not be 1.
Oh, okay.
Right? Your molarity is telling you have 1 mole of NaOH per 1 liter, but it doesn't tell you how much volume you have. You could have 1 mole per 1 liter, and you could have like a spoon full of that. Or you could have a bucket full of that. Or you could have a swimming pool full of that, because all that is a ratio. It's saying for every 1 mole, you have 1 liter, but I'm not telling you how many liters you have, right? You could have 100 moles per 100 liters, and you would still be at that ratio. You could have 1/4 of a mole for every 1/4 of a liter, and you would still be at that ratio. Does that help?
Yeah.
Yeah. Ooh, good concepts we're working out. Awesome questions from all of you. An original mystery person who broke the ice for us. I appreciate you.
That was me, Lexi. You're welcome.
Okay, good job. Good job, Lexi. I'll start to recognize your voice eventually too.
Perfect. I don't usually talk, so that's probably why you didn't.
That's probably why. Okay, let's do the next Let's try this one. Let's try the top one. I'll give you a 30-second head start, and then I'll start working. Let's see if you can beat me there. Okay, give me a thumbs up if you beat me there. Hey, a couple of you. Any questions? Beat me to part of it. I'll take that. Questions? Comments?
I just assumed that the ratio is 1-to-1 because I didn't write out the whole formula. Is it normally gonna be 1-to-1 ratio, or does it just depend on the question?
So it depends on what your reactants are. Where you're going to get really familiar with neutralization reactions, especially once we go through that acid-base chapter, which is not until later in the year. You should, until you get really familiar with them, you should write them out and balance them and double check to see that they're balanced. But with acids and bases, acids only give off one hydrogen at a time, right? And so if you have an acid with a base that only has one hydroxide, it's always going to be a 1-to-1 ratio. If your base has two hydroxides, then it's going to throw off your ratio.
Okay.
Good question. Other questions?
I had a question about what's in the solution. Do we have to balance the equation to figure out what's in the solution, or can you just guess kind of by what the charges are and stuff like that?
You should balance the equation in order if you need to go between two different molecules. Like, for example, we have to go between nitric acid and water. So because we're changing molecules, you should write out the equation and balance it. If you weren't changing molecules, you wouldn't have a need for a reaction. Does that answer your question?
Yeah, thank you.
Okay. Hey, if you don't have questions, but you want to try a couple more of these, there's two more at the bottom, and the answers are located below, very, very small. So while we're answering questions, you can always go ahead and try one from the bottom and see if you come out with the right answer. Other questions on this? Questions like, how do you know what to start with? Or I started here, would this work too? Or why did you use something? Any questions?
Will you always convert it to liters? Like how this question is 25 milliliters, will you put it to 0.025 liters?
Yeah, good question. I do. I always convert it into liters. There is a catch. If you're going out of milliliters for like nitric acid and then back into milliliters for something else like water, if we were doing that, you actually wouldn't have to convert out of milliliters because the conversions cancel each other out. But that's a lot of thinking ahead that I don't like. I can't process that much information in the middle of doing a problem. So I always switch into liters when I'm dealing with molarity. If you're not dealing with molarity, then you don't necessarily have to convert out. But since the denominator of molarity is liters, I always switch milliliters into liters. And that way I don't just make a silly mistake. Yeah. But if your mind can process that whole like, well, I convert out here, but I convert back in here, then you don't necessarily have to. I just don't like carrying that much as I try to process. Other questions? Okay. Nice. Let's move on. You did that one. Okay, let's try this question. I'll give you some time to think about it and ask. Feel free to ask questions as you're reading through. Any questions before I start?
What's the significance of the when they say the range of 3 to 6 molar? Are they just trying to throw us off there, or does that matter?
They're just giving you fun information.
Okay.
All of this actually, is just like for your enjoyment. You don't need any of it.
Okay.
And in fact, when I'm reading questions on tests, I always read the last sentence first. What is the concentration of the NaOH solution? Because then I know, like as I'm reading, I already know what I can skip and what I can't. So test taking strategy, read the last sentence first, especially if they're long questions.
What do I do with the 20 milliliters? Because for like, I do the 45.7 milliliters times the 0.5 moles per liter. But what do I do with the 20 milliliters?
So if you start at the end, what's the concentration of NaOH, right? Concentration is going to either be in moles per liter or grams per liter. So moles is going to be easier for us because we are dealing with a reaction. Okay, so our ending answer is going to be moles per liter. what do we already have? Do we have the moles of NaOH, or do we have the liters that are in solution?
The liters.
Yeah, so there's where your 20 comes into play, because it is the denominator of your answer. Also, fun fact, when acid names get long, I don't write the acid name. I write HA, because H is going to be my H plus that comes off of my acid. A is going to be everything else. It's the anion that's attached to the hydrogen. So I just save myself time by not writing out the whole name over and over and over. I just write out HA over and over and over.
Why is it a 1-to-1 ratio?
In the reaction,
Yeah,
what would you want it? What would you expect it to be?
I thought it'd be because you're just taking one H away. Never mind.
Yep, you got it. Okay, that's what I got. Who beat me there? All of you have different answers. You're scaring me. Did I do the calculation wrong? 45.7 divided by 1,000 times 0.5 divided by 0.02. Oh, I did do it wrong. One point 1.14. 1.14. All right. A couple of you guys beat me there. Good job. Questions on this one, or comments, concerns?
So a lot of the questions on the quiz on Monday, will it be like these? A lot of them just like finding the molarity and the moles of these equations?
Right. So the mole math, that like stoichiometry math, is a big part of this chapter. I mean, if I were to go through and look at the book and see like where they spend the most time, I mean, some of it's conceptual, but they spend quite a big portion of the time going over dilution calculations, molarity calculations, and neutralization calculations. So I think it's fair to assume that you're going to see a lot of those on the test. They're going to be AP style questions, right? But probably a lot of those on the test. Questions before we move on? Let's do this one. Questions before I start?
When you start, do you convert the grams to moles? Because they give you the liters, so you convert grams to moles.
Yep.
Okay.
I'm confused on how you should like organize the information to figure out like what you have.
So I would start at the end since we're calculating concentration, right? I want moles per liter of NaOH. I would go from there. Do I have anything from the get-go? I have volume. And so instead of like starting with the information you have and processing forward, I would go backwards, because then you're going to go look for what you need instead of trying to take all the information in and figure out how to synthesize it. You're just going to go look for pieces as you need them. That's what I would do.
I'm kind of confused on how to know what what the products of your reaction are going to be.
Okay, so let's write out so you're going to have KHP. They tell you it has one acidic hydrogen, so NaOH, and they're telling you it has an acidic hydrogen, which means it's an acid, right? So our reaction is between an acid and a base. So your products are always going to be water. And if it has one acidic hydrogen to one hydroxide, it's going to be a 1-to-1 ratio. And then you're going to have a salt, which is going to be Na, and then whatever else is left from the KHP. I mean, technically, if you want to know, like we could just, it'd be H plus KC8H4O4. So this would be your anion that would get connected to sodium. But you know, since it has one acidic hydrogen, you know it's going to be a 1-to-1 ratio. And so we don't really need to know what this salt is unless they ask us something about the salt, which they don't. And so this is kind of the same answer that I gave to Callie. Like, if you work backwards, you're going to go find information that you need as you need it, compared to trying to use every piece of information in the problem, which could end up very confusing. Hey, look at you guys go. Yes. And technically you should be keeping 4 sig figs. But again, sig figs are not worth very many points. Questions? So one way that I see you guys growing through the questions that I hear you asking, I'm recognizing that you're growing through, like you're getting better at processing through story problems. You're getting better at applying math to context. You're applying math to specific contexts. You're getting better at sorting through information. Like all of those are skills that we kind of just do and we don't really think about them until they really push us, like right now. But you guys are getting better at those. Just in asking the questions that you're asking, I can hear that you're asking more specific questions, which means you're getting better at these skills. Okay, it is 11:39. I'll stop talking to give you guys a chance to ask final questions, and we'll kind of just pick up here tomorrow, and we'll keep working through these practice problems.